Sir, 1 minute. Very good morning to all. It's my pleasure to welcome you all for the 5th day, 13th session of Intelligence Computing in Data Science FTP. On behalf of SKCET, I welcome our resource person, Mr. Sridharan Sankaran, AI Capability Head, CTO Research Group, TCS Research and Innovation, and all the participants from various institutions. In this session, we are going to discuss about ethics and AI. So before going to start the session, I would like to give brief introduction about our resource person, Mr. Sridharan Sankaran sir. He completed bachelor's degree in electronics and communication from University of Madras during 1985 to 1989 and Masters of Science in Computer Science from IIT Madras. He started his career as a scientist in Indian Space Research Organization from 1990 to 1992. Then he worked as a head insurance practices in Australian and New Zealand during the year 2004 to 2007. He joined in TCS and had taken up many roles from 1993 to 2007. Then he worked as senior project manager in Harvey Norman during July 2007 to March 2008. He worked as a director project in CTS from December 2008 to March 2011. He worked as delivery head research and innovation during March 2011 to August 2017. Presently, he is working as a head AI ethics governance since September 2017. His strong skills include software development lifecycle, requirement analysis, and software project management. Thank you, sir. Thank you for accepting our invitation. Now I hand over the session to our resource person, Mr. Sridharan, sir. Sir, please carry on, sir.
Okay, thank you. Let me share my slide. Can you hear me?
Yes, sir. It's audible.
Okay, fine. Okay. Just a sec. Are you able to see my slides? Okay. Okay, fine. Good morning, everyone. Thanks very much for inviting me today to talk about ethics and AI. I went through the various topics that the various speakers have talked in the past few days, and I find they are all quite technology intense and very interesting topics covering data science, artificial intelligence, machine learning, and those concepts. And there are even some topics going down to the code level, TensorFlow and so on. Today, I'm going to talk about a topic which is not that technical. It's partly technical. So it is a mixture of technology and behavioral science, as we call it. So it's about ethics and AI. Okay, so while we go through this presentation today, we will cover why ethics is so important and what is ethics, why it's important. And we'll just briefly touch upon AI, and then we'll see how ethics and AI meet and where do they meet. And now this ethics and AI is a very hot topic. As we advance in the field of artificial intelligence, starting from artificial narrow intelligence where we are now, where your AI system does a very narrow task, of, say, identifying an object or classifying an image or recognizing a speaker and so on, is a narrow task. So one AI system can do only one narrow task. From there, we are moving towards artificial general intelligence, where an AI system can do multiple tasks. And from there, probably in the future, artificial super intelligence, which we see in all the movies, a robot can do anything. So probably that will be the future. But as of now, we are well established and in the artificial narrow intelligence. And even at this stage, we are facing so many ethical issues, and companies are uh, putting in so much effort and investment into addressing these ethical issues. So let's go through that in this presentation. Okay, we every day, perhaps not every day, but in our life, at times we do face some ethical, situations where we have to choose one over the other. And we would have taken some decision or the other based on the situation. So let us look at this figure that I have. So here is a trolley as in it's like a small train carriage that is just rushing. And there is, if you don't do anything, this trolley is going to come, and you can see some 4 or 5 people tied to the railway line. And this trolley is going to run over them. Now, there's a man, that's what you are standing there, and there is a lever there. If you want to, you can operate the lever, and then the trolley will divert and take that other route. And there is only one person tied. So you have an option to choose whether 5 people are going to die or only one person is going to die. So what will you choose? So if you don't do anything, 5 people will die. If you do something, you pull the lever, then it takes a different path and only one person is going to die. So what will you do? So I think this is fairly simple thing. I mean, ideally, we don't want anybody to die, but fairly, this is a straightforward problem. And solution is you would operate the lever so that instead of 5 people, only one person dies. Now let's make it a bit more complicated. What if that one person is somebody beloved to you? So what will you do? Right? It's very difficult. I mean, I don't have an answer, and perhaps nobody has an answer. But such ethical dilemmas, ethical conundrums we do face in our life. So the question is, then what is ethics? Right? Few years back, a sociologist by name Raymond Baumhart, if I remember, met some business people, and then he asked one simple question: what does ethics mean to you? What does that word ethics mean to you? And one guy said, ethics has to do with my feelings, and whatever my feelings tell what is right or wrong, that's what is ethics. And another guy said, ethics has something to do with my religion, so religious beliefs. So religion, what a religion says, that is what is ethical. A third guy said, being ethical is doing what the law expects me to do. Another guy said, ethics consists of standards of behavior. So there are a set of standards which our society accepts. So whatever our society accepts, that is what is ethics. And finally, one guy said, I don't know what ethics is. Well, these replies might be typical of our own. The meaning of ethics is hard to pin down, and the views many people have about ethics are a bit shaky and not well defined. Like this first respondent that we talked about, many people tend to equate ethics with feelings. But being ethical is clearly not a matter of following one's feelings. In fact, feelings frequently deviate from what is ethical. Right? As we saw in that previous slide, if that person feels, no, this person is my beloved person, I can't allow that person to die, then where is ethics there? Right? Nor should one identify ethics with religion. Most religions, of course, advocate very high ethical standards. Still, if ethics were confined to religion, then ethics will apply only to religious people. So what about atheists? Are we saying atheists don't have ethics? No, we can't say that. So religion can set high ethical standards and can provide some good motivation for being ethical, to exhibit ethical behaviors like, be compassionate, be truthful, and so on. But ethics, however, cannot be confined to religion because it has to apply to people who don't believe in religion also. Okay, so being ethical is also not the same as following law. Like one of the respondents said, it's about following law. It's not about that. Because law often Law often incorporates ethical standards, which most of the citizens will subscribe. But sometimes law can also deviate from ethics. For example, in South Africa, we had, for a very long period, we had that discriminative law, like against the blacks. So we can't say law always goes with ethics. Finally, being ethical is not same as doing whatever the society accepts. Okay? In any society, most people accept standards that are in fact ethical. So usually it will be there. But standards of behavior in society can deviate sometimes from what is ethical. Okay. For example, in the Nazi period, the Hitler's period, in Germany, the entire society was morally corrupt. It was not ethical. You were just killing people. So we can't say that we'll go by what the society does. So moreover, if it is about society, then how do you know what society wants? So you have to go and then do one survey and then find out what society thinks about each and everything. For example, what should I do? What should I feel about abortion, for example, as a concept? So I have to go and then do a survey and then find out what that the society thinks and then take action based on that, which is not possible. And sometimes society, there won't be any consensus. Some people will think one way, others will think the other way. So you can't have a consensus. So you can't go by what society does. So what do we do? So is it confusing? Right. Okay, so ethics is two things. Firstly, ethics refers to some well-found standards of right and wrong that prescribes what humans should do or humans should not do. This is in terms of rights, obligations, benefits to the society, fairness, such virtues. For example, ethics refers to standards that impose a reasonable obligation to refrain from stealing or assault or fraud. So ethical standards also include those that enjoin virtues of honesty, compassion, loyalty. All those are also ethics. Okay, so such standards are adequate standards of ethics because they are supported by consistent and well-found reasons. So these are called fundamental rights. So even in Indian Constitution, if you see, we have something called fundamental rights. Right to free speech, right to follow your religion, this, that. So these are some fundamental things. Secondly, ethics also refers to the study and development of one's ethical standards. So you set certain standards for yourself and then you keep observing yourself and then you see how you develop yourself ethically. So that is also ethics. So as mentioned before, feelings, law, religion, social norms, all this can deviate from what is ethical. So it is necessary to constantly examine one's own standard to ensure that they are reasonable and well-founded. So ethics also means then the continuous effort of studying our own moral beliefs and our moral conduct. Okay, so enough of this. So if I have to summarize, we can say ethics is a set of values and principles that guide the way in which we behave as individuals and as a group. Okay. See, this problem of ethics in AI is not something new, because for ethics, the problem of ethics has been there in other technology and scientific research areas also. For example, you have, I have listed some of them, scientific research and innovation areas where we are already facing ethical issues. For example, this stem cell research, if you look at it, so there is something called embryonic stem cell. Okay, so in research with embryonic stem cells is highly debated, and many people have very strong opinions one way or the other about it. And some say it's highly ethical. I mean, some say it's okay, it is ethical. Some say no, it's highly unethical, and so on. So both sides of the debates are interested in protecting human life, but still they have very different opinion and standpoint. So why it is so different? So it comes down to how the human blastula is viewed. So what is human blastula? See, embryonic stem cells are primarily made from cells found in human blastula. So what is it? It is one of the earliest stages of human life. So a fertilized egg goes into a blastula. So a blastula will have only some 100 or 200 cells. That is the stage, which can only survive for a short time, before which it has to be transplanted into the uterus. So in all this fertility clinic, this is what happens. You know, they what we those days used to call as test tube babies, and all that. They create that this blastula, and then they transport it into the uterus. See, this blastula they create so many blastula, but everything will not be used. So usually they just discard the unused ones. But this blastula is used in research, and they can be harvested, isolated, cultivated in the laboratory. Okay, and they can be potentially be used to replace or restore tissues that have been damaged by diseases or injury, such as diabetes, heart attack. I mean, all these things you can use these embryonic stem cell blastulas. So it can even be used to treat Parkinson's disease, spinal cord injury, and so on. So some people are seeing that destroying a blastula for itself as destroying an unborn child. So people who think that it is unethical say, no, you can't destroy it, because it's as good as a child, it's as good as a baby. Others feel no, blastula is not a baby yet, because unless that blastula is extracted and then it is attached to uterus, it will never become a baby. So it's not a baby. Still, you are not killing a baby or anything. So two very different views on this. And that's the reason in many countries it's still banned. So every year, fertility clinics produce so many blastula, but they are all produced in surplus, but they are all destroyed. The supporters of this embryonic stem cell research generally feel that using these cells from these surplus blastula for research is much better than just throwing away, and the other group doesn't agree. So I just gave an example of this ethical dilemma which is there in other areas. So we come to the ethical problem in AI next. Before that, let's pause and say, what is this AI? I mean, in such a forum where everybody has gone through so many lectures about machine learning, data science, and AI, this question might look very trivial. But I just wanted to spend a few minutes, set the stage, and then before we go, because there is still a lot of uncertainty among some people. Very few concepts are poorly understood as AI. See, if you take, there are many opinion surveys that show that even top business leaders have some confused notion about AI. And if that is so, then think of ordinary people, how confused they will be. So many think that it is something to do with super-powered robots and hyper-intelligent devices. And to make things worse, Hollywood has already done its bit. It has, all this advanced Terminator type of Skynet, which will come on and destroy the world, or this HAL type of thing, missions that you find in that Arthur Clarke's 2001 Space Odyssey type of stories, which goes rogue after humans decide to defuse and disable it. So lack of clarity around the term AI enables technology pessimists to warn that AI will conquer humans, AI will suppress individual freedom, AI will destroy personal privacy, and so on. Right? Part of the problem for this confusion and lack of clarity is there's a lack of uniformly agreed definition. Alan Turing, who who is credited with the origin of the concept of all these thinking missions. In 1950, he talked about thinking missions that would reason at the level of human intelligence. He came up with this Turing test, which specifies that computer needs to complete some puzzles, some reasoning puzzles, as good as human being in order to be considered as thinking. If it has to qualify as thinking mission, then it should also be able to do those puzzles on par with human being in an autonomous manner. Okay. Turing was followed by a few years later by John McCarthy, who first used the term artificial intelligence. This is mid-50s. So this AI term has been there for what? Some more than 50, 60 years. So he used the word artificial intelligence to denote missions that could think autonomously. Then since 1950, scientists have argued over what constitutes thinking and what is intelligence and so on. So let's go with this safe definition, which is artificial intelligence refers to the simulation of human intelligence in missions that are programmed to think and act like humans. This is not the only definition. There can be alternate definitions which are equivalent to this. So we'll just leave it here. Now, if you look at what all should qualify as AI, this again, in today's world, I've been seeing this. Whenever we use the word AI, people will equate it with machine learning. And immediately they will say machine learning means deep learning. So AI is equal to ML, ML is equal to DL. So in a restricted way, there is an association between AI to ML to DL, but they are not synonymous. That's what I'm trying to say in this slide. Artificial intelligence covers so many things. And this ML DL is just one way of achieving artificial intelligence. There are so many other ways for building an AI system. For example, natural language processing. This can be done with or without machine learning. Speech recognition or speech transcription or speaker identification, speaker verification, all these speech-related use cases. Some of them can be done without machine learning or deep learning. And this expert systems is what initially we started with in those AI, when we started AI, rule-based engines and so on. And there are also like computer vision, which is like object detection or image classification, and then identifying something in the video and so on. And some of these can be done without a machine learning approach. But if you go with the machine learning approach, there are two types of machine learning approach. One is, deep learning is also a type of machine learning approach, but there are non-deep learning approaches also, which is sometimes people call it as classical machine learning. So all this is AI. So AI touches upon so many domains, so many use cases, and can be implemented in various ways, and not necessarily using deep learning and machine learning. But why we use deep learning, there's a strong reason. Now slowly we are going towards deep learning. We have a reason for that. We'll talk about that. But I wanted to show this slide to say that AI is not just deep learning. That's all in this. Okay. And there are many pessimists out there who say AI is a big problem. And so some of the things that they say is people might have too much leisure time because of all this AI. But interestingly, Arthur Clarke in 1968, he said this: people in 2001 might be faced with a future of utter boredom where the main problem in life is deciding which of several hundred TV channels to select. And I think now we are doing that. And in those days, having more than one TV channel was unimaginable. But he talked about that. So that is one thing which people say. Then people say the standard one, people might lose their jobs due to automation. So it's going to be a risk for job loss. Okay. So this type of argument I have heard even in the early 90s. So in the early 90s, when there was a period when I joined ISRO, at that time this computerization of banks was coming. So at the time there was so much of restlessness among the bank employees saying no, computerization will take away our jobs, say no to computers. There were strikes and all that happening. But can we imagine today a bank without a computer? It's just not possible. But has it resulted in job loss? Maybe very little. But now, even though there are computers, still you need people to operate those computers. So just the job, as the type of job that they did has changed and then made their life easier. So you have machines to count currency, you have everything in your computer. So if you have, in those days, they used to update passbooks with hand, and they'll make some mistakes there also. Now you don't need to. I mean, now even passbooks are going away. You see everything on the internet. Anyway, so such pessimistic views have been there during bank automation day, and now we are seeing the same now. People might lose their sense of being unique. Like today, AI is able to compose music, if you know. So they give a lot of music as a training example, and now it's able to compose music. So if I'm somebody having an individuality that I can compose music, and if it is being taken away, or if anybody who has that AI application can compose music, then what is my individuality? Is a question. People might lose some of their privacy rights. This again, we will talk about it much later, but there is some truth in that. So we'll talk about that. Then use of AI systems will lose in accountability. So you are talking about self-driving cars and automated, like you go and then say, I have fever, I have this problem, I have stomach problem, this, that, and then let's say computer AI system tells you this is perhaps your illness, take this medicine. And finally, the diagnosis is wrong. Who is accountable? If a self-driving car goes and crashes, can you go and arrest a car? You can't do. Will you go and arrest? Then whom do you arrest? Whom do you? Is it one person because it's a company that has manufactured? Do you go and then arrest everybody there? Whom do you? So these sort of accountability issues are there. And the people say that AI will totally take over, and then the human race will be wiped out. All these Hollywood movie type things. Okay. So the question is AI dangerous? Okay. AI will be the most disruptive technology over the next decade. The quality of this technology has improved considerably in a number of areas in the recent years. Okay. Yeah. So smart software systems gain an even better understanding of who we are, what we do, where do we go, why do we go, what do we do there. So everything it's possible to capture. That gives you a world full of opportunities, right? So there are chat bots, chatbots, right? Many times, I'm seeing the website, you go and then there'll be a chatbot. It will say, how can I help you? You go and then type, okay, I'll assist you. So if you are not talking to a human, you're talking to a chatbot. And there are smart virtual assistants such as Siri in iPhones, or Google Assistant in Android phone, or Amazon Echo Dot, right? And this Alexa stuff. And they are all coming to our aid. Just as it is difficult to imagine living without internet, living without electricity, a decade from now, we will see the same scenario in terms of our personal assistant. These personal assistants, which I just mentioned, we are going to be dependent on them. They are going to play a major role in our life. And this is not something very futuristic, but it's going to be a reality, and we are already seeing it. Let's talk about some specific examples. Smart computer systems are able to recognize art forgery. If there is a artistic work and it looks exactly like original, human eyes cannot identify, but today we are able to use an AI system to find out if it is original or forged. There is another AI system which is able to recognize dementia. Dementia is a mental, decline in ability with age. And it is able to do it even before a healthcare professional, a doctor, is even able to identify it. An AI system is able to recognize skin cancer. Just give a photo of that area of skin, and then it will say whether it is cancer or not, or it will say whether your nail has fungus or not. In fact, researchers from Stanford are able to predict voting behavior in elections based on Google Street View images. Okay, so even Facebook knows when you are dating someone before you go and then declare it openly, based on all the chats that you are having. Okay. In fact, Amazon has a patent on predictive shipping, where they are able to send your package even before you know you want it. So they're just observing all your interactions, all your activities in the Amazon app or the Amazon website, and they are able to predict that, yes, this person is going to buy it. So this predictive value of AI is phenomenal. Okay. But we also have to be cognizant about the fact that there are some downsides. Some notable individuals, some notable people, legendary people like Stephen Hawking and Elon Musk, they all have warned about AI, that it can be potentially dangerous. At one point, even Elon Musk said that AI's danger is as dangerous as the dictator of North Korea. That much he was. Even though we have not achieved super intelligent missions yet, AI is even in this narrow intelligence mode, AI is already posing a lot of risks. So we'll just go through this. Some of them I have listed. See, this autonomous weapons program, which many superpowers have started working on, is something which is going to be very dangerous. Okay. And these are all straight away challenges to the ethical behavior. It might be even reasonable to expect that nuclear arms race will be replaced with a global autonomous weapons race. As Russia's president Putin said, artificial intelligence is the future, not only for Russia, but for all humankind. It comes with enormous opportunities, but also threats that are difficult to predict. Whoever becomes a leader in this sphere will become the ruler of the world. This is what he said. So the countries are moving away from nuclear weapon and going to autonomous weapons. The social manipulation is another thing. Social media, through its autonomous powered algorithm, which algorithms that just operate on their own, is very good in effective targeted marketing. So the social media companies know who we are, what we like, and they have notions about what all things we do on the website. In fact, there's one Cambridge Analytica, if you know, a company, and there are a few others associated with the company, who use the data from 50 million Facebook users to try and influence the outcome of 2016 US presidential election. And they did the same with UK's Brexit referendum, the referendum where UK decided to move out of the Europe umbrella. So still investigations are going on, and it's still some time before it is proven and all that. But still, if the accusations are correct, it illustrates AI's power for social manipulation. It is also alleged that the same Cambridge Analytica offered to influence voters in 2019 Indian Lok Sabha elections, and it approached a political party in India to offer its services. Anyway, so nothing is proven yet, but these are all allegations. So by spreading propaganda to individuals identified through algorithms and personal data, AI can target them and spread whatever information they like in whatever format. Doesn't matter whether it is fact or fiction. They can still push whatever they want to push. They can push it to a targeted audience. So that is what is called social manipulation. The next problem is invasion of privacy. It is now possible to track and analyze an individual's every move online, as well as like what are they doing daily, right? So cameras are there everywhere now. Facial recognition is possible. So with that, it is possible to track what you are doing. So you search on Google Maps, so Google knows where you are going. You use Google Pay to pay something, so Google knows how much you paid at that particular location, and so on. So you can keep adding, right? And this type of privacy intrusion is being used by China to come up with a social credit system, by which it is going to give every one of its 1.4 billion citizens a personal score based on how they behave, right? So do they jaywalk? You know what jaywalk is? Like, there's a road, you don't care about signal, you just walk on the road. So the vehicles have to brake, they have to stop for you, and you just walk. So that's called jaywalking. So do you jaywalk? Do you smoke in a non-smoking area? Do you play music loud in public place and then distract others? How much time you spend playing video games? So anything can be traced and tracked now. And based on that, China is giving a score for everyone. And based on that, citizens could lose certain rights. If you have done so much of things, then government will say, no, you can't book a plane ticket for the next 6 months. You can't book train ticket for the next 1 year. They can decide, or you can't buy a property, you can't to get a loan, so on. So when this big brother is watching you and making decisions based on those inputs, it's just invasion of privacy, and it can quickly turn into social oppression. Okay. Next thing is discrimination. Since machines can collect, track, and analyze so much about you, it's very possible for these machines to use that information against you. It's not hard to imagine an insurance company telling you you are not insurable, which means I won't issue an insurance policy because you have used mobile phone and then you have been driving and cameras have caught that, and we have got all that input, how many times you used your phone while driving, and that's all evidence is available in camera, which because your face recognition is already done and you are using a phone, that is object detection is done, and camera, so many cameras everywhere, maybe there is a consortium of camera where you can get the data, it's possible. So all that is possible. So an employer might even withhold job offer based on your social credit score, which means what's your social standing, what's your social trustworthiness. That is again possible because you would have said everything about yourself in Facebook. Starting from start of the day till end of the day, what all you have done, you go and then you post your photo, you go and then give updates. So it is just a matter of an algorithm to just go through all the chats and what, go through all your posts in Facebook or Twitter or Insta or whatever, to know about you, to know what are your views, to know how abusive you are, what is your political inclination, and whether you are a polite person or whether you're a nasty guy. So everything is possible to, it is possible to analyze from all the posts that you have made in social media. Okay. Now, we'll quickly go through some of the failures that have happened with AI and how those failures have directly impacted ethics. Okay. Some failures that have resulted in ethical issues. Microsoft came up with a chatbot called TAE. This was a few years back. So Microsoft launched its version of this TAE for Twitter users. This was in, I think, 2016. It was programmed to have a casual conversation in the language of a typical youngster, typical millennial guy. Okay. So how it will know? So it started interacting with people and then picked up that language and then started using it. Okay. So what happened was, according to Microsoft, this TAE leveraged AI to learn from all these interactions to hold better conversation. However, what happened? Within 24 hours, this chatbot was pulled out and discontinued. Reason was targeting its vulnerability. Some of the hackers, these mischievous users, trolls, they started manipulating this chatbot. They started chatting with it in an abusive way, started chatting with it in a racial way, in a gender biased way. Then this chatbot started learning all those languages, started learning all those sentences and words, and started using it on others. So soon, within 24 hours, this chatbot became a nasty chatbot using all sorts of unethical language. Okay, so it has to be discontinued. So this is an example of your AI system can only be as good as your training data. This is an example. So finally, Peter Lee, who was Microsoft corporate VP for AI and research at that time, he issued a public apology and then said Microsoft take full responsibility for not anticipating this possibility of misuse ahead of time. Okay, so this is one example. There's another example of AI going wrong, creating ethical issue. This was with Amazon. So Amazon was receiving so many resumes, they were not able to manage manually. So they decided to use a AI-powered system to do some filtering of these resumes so that it will shortlist. Okay, so they have been building this machine learning program since 2014 to review this job applicant resumes. So what this did was, the company, this hiring tool used AI to give this candidate some score of 1 to 5. It is like they were treating candidates like their Amazon product. Like in Amazon, you like it, you give a 1 star, 2 star, 3 star rating, like that. So this AI tool system was trying to rate these resumes. So what really Amazon wanted was, if this AI system, if they give 100 resumes to this AI system, it will rate and then pick the say the top 5 based on some criteria. It will pick automatically 5 people, and only these 5 will be called for interview, and one will be selected. So this is, the intention is good, because they don't have the time and resource to go through all 100. So they wanted some initial filtering using AI. Fair enough. But what really happened, what they really found out, was that this AI system did not like women. It was biased against women. They found that this AI system was not recommending any women at all, shortlisting. That is because Amazon's computer models were trained to shortlist applicants by observing patterns in resumes submitted to the companies over a period of 10 years. And most were men. Historically, those whatever they gave as training, they were all men. So it is a reflection of male dominance across tech industry, but that doesn't mean that a good female candidate should be rejected. So in effect, Amazon's AI system taught itself that male candidates were preferable and they were more qualified. So it penalized resumes that included the word such as women, or it's explicitly if somebody had said gender, or if somebody had said, I was a member of women's tennis club, or some word indicating that this person is a woman, or it can even pick up from the name. So it was just rating these candidates down, and eventually Amazon had to dismantle that team, and they had to drop that project. So this Compass criminal risk assessment software. This is another thing that happened in US, by the US government. So what they did was this system ideally was meant to give a recommendation to the judges based on various parameters about the accused. So there is an accused, and this accused has various parameters, maybe family background, what is his history of other criminal activities, how old is he, and whatever, is he in a poverty situation, so many parameters. And then it wanted to give a recommendation to the judge saying, this person, if you give bail, he will just escape. Or if you give him lighter sentence, he will again do the criminal offense. So that sort of recommendation, that's the intention. Then what happened? A ProPublica, it was a not-for-profit organization. They assessed and analyzed this software, and they found that this software was highly biased against blacks. So it was discovered that this Compass algorithm was able to predict particular tendency of a convicted criminal to reoffend. Fine. But what happened was it was always predicting twice the amount that the blacks will reoffend. Blacks will jump bail or whatever. When it came to whites, it was very lenient. It was saying, no, this guy is a nice guy. He can be given bail. So why that bias? Why that failure happened? Because of the biased data given during training the AI system. Okay, so that is about that AI failure. And there is one another problem that happened in the UK. An AI system was used to estimate exam results, and based on that, college admissions were given. So the algorithm worked like this. So teachers were asked to supply for each student an estimated grade and a ranking compared with every other student in the class. Then these were put into an algorithm which also then factored in the school's performance. So teachers give how is this student and how is this student as compared to others in the class. So this is what the teachers give. Then this algorithm also took the performance of the school in the past 3 years. So this algorithm took all this together and then started giving some estimate of scores, which was used for further higher studies admission. But problem is this introduced a lot of bias. Firstly, private schools always, historically, they have always outperformed government schools on exams. So in UK also, we have this government school and private school. This is because these private schools are all well funded. They are very selective about whom they admit. Their class strength is less. And they always attract students from highly educated and wealthy family. Whereas the government schools are less funded. They attract the poor students from less educated family. So if you are a top performer in a government school, still your grade will come down because it is a government school whose performance overall has not been that good in the past 3 years as compared to a private school. Okay, so this bias has come into the decision making. Secondly, the predicted grades were given greater weightage by the algorithm if the class size of the subject of the particular candidate is less than 50. But government schools add at least 30 students. So naturally, all the private schools where there will be only 10 to 15 students per class, all their predicted scores got hiked up. So what was the result? Millions of students got downgraded results, and it's very unfair. Perhaps many of them will be unfair. And in many cases, this cost students in a place, a good university or good college, and spoil their future. So after a few weeks and a lot of protests and all that, finally UK government agreed to that, and then they dropped that. Okay, now we come to where ethics and AI meet and what we should do to have an ethical AI system. Okay, so there are some founding principles. How am I doing this time? Okay, there are some founding principles for ethics in AI. Okay, so one is safety or reliability. So safety and reliability is one. So if it is autonomous car, it has to be safe. If it is a system that recommends you a medicine for an illness based on some symptoms that you describe to the system, then it again has to be safe to you. Second is privacy and security. Like now AI system, like all this ML, DL algorithms need a lot of data. So this data has so much of information which is confidential, private, and it is very important that the data is secure. It is important that privacy is maintained. So AI systems should be designed such that the privacy is not violated. Another is AI system should not discriminate. It should be all inclusive. It should not discriminate based on religion or race or gender or ethnicity or whatever it is. So if these parameters are present in your input, it should not matter. A decision by the AI system should not be based on such parameters. It should be all inclusive. And an AI system should be transparent. It should be explainable. Meaning, if a AI system makes a prediction, it should have a sound reason, and that should be explainable. So if I want to go and then find out why it made that decision, let's say a loan application is rejected by the AI system, then there should be a way to find out why it rejected. Now that's becoming a problem. See, in those earlier days, when we wrote non-AI software, it's very simple. If there is a error, we can just go and then do a code walkthrough. Okay, there is a if statement here, it's going here. Oh, here is the reason, because there's a wrong code here. So you can do a code walkthrough. But with this MLDL type of systems, you can't do, because it's just based on huge data. It keeps training, and then it adjusts the weights, the parameters, and then finally it gives you a model. So how do you go and then find out? You can't do a code walkthrough here. Code is fine, but it's just a data which is getting trained and it is biasing. So there should be a way to explain. If somebody asks why that decision was made, there should be a way to explain. So that's a transparency. And then accountability. If a self-driving car goes and then crashes, who is accountable? It's a question mark. And there are also legal issues with AI. We'll not go there because it's more about ethics and not about law. But in general, ethical AI is all about, it should be fair, transparent, and it should be human-centric. So AI should just do what a human being will do, a considerate human being will do, an ethical human being will do, just that it is doing in a much better way, faster, and in a more reliable way. That's all. That is what is expected from an ethical AI system. So if you look at what are the features of an ethical AI system, firstly, the ethical AI system should be algorithm agnostic, which means what type of algorithm, machine learning algorithm I use should not matter. Whatever algorithm I use, it should behave ethically. Right? Secondly, it should be technology agnostic. Whether I use this language, that language, whether I use TensorFlow, whether I use Keras, doesn't matter. Whatever may be the technology, whatever may be the technology frameworks, tools, it should still behave the same way ethically. And it should be industry domain agnostic. So it should form the baseline set of considerations. So whatever may be the sector, whether it's the banking, insurance, whatever, the fundamental ethical principles should not change. If you say no, banking customer is okay, I can privacy is not important. So you can't have such domain specific, that is industry specific rules. So it should be agnostic. Agnostic meaning it should be beyond all this. And it should be scale agnostic, whether it is a very simple AI system or it is something which is going to process 1 million example records, it doesn't matter. So it's still it should be ethical. Okay. So of this, let's talk about some of the aspects of ethics. Okay. Let's first talk about bias and fairness. Bias is a systemic error in data. A systemic error in the data or in the model that can possibly, there's a difference between data, algorithm, and model. Sometimes people use algorithm and model interchangeably, but data plus algorithm is what gives you the model, right? So if you use a different data but the same algorithm, it's a different model. So for that training data, for that algorithm, when you use that algorithm to train on that training data, you give one particular model. Okay, just to clarify some terminology. So so there can be systemic errors in the data or the model that can possibly influence the decision of a AI system. Okay, but bias manifests when it plays a role to influence decisions. Okay. Whereas fairness is a measure of providing equal opportunity to both the privileged group and the unprivileged group. Okay. So that's what you're trying to be fair to both, right? So I'm just getting into some of these terminologies. This fairness is a multifaceted concept that depends on the context also. So it may not be possible to build an AI system that is universally fair. But as long as the AI system is fair to the specific purpose or the intended goal, then we are okay. When it comes to bias, there are various sources of bias. It has been recorded somewhere, I read, that there are 180 types of cognitive bias that have been identified that can come into the AI system. We'll talk about only a few of them. One is called a historical bias, which is like a social perception change bias. Such things can happen over a period of time. For example, equality of women for jobs and parity of women's pay, parity of women's pay and men's pay. These are things which would not have existed many years back, but now it is there. So if you use a training data of past and then train a AI system, it will still have that bias, and so your output will be biased. So if the whole data is used to select people or determine the pay of somebody, salary of somebody, all this negative bias can come in toward against the women. Another is called sampling bias. This type of bias creeps in if the data is not collected randomly from a large group. Okay, so for example, if let's say like you go and then collect data from light-skinned people who are vulnerable to certain type of skin cancer. Then you should also collect data from dark skinned people. So you can't just collect only from light skinned people and then build a AI system. So you have to take samples from all groups. One can be a white skin, another group can be a black skin, another can be a brown skin. So you have to take data from all groups. Then only your sampling is correct. Otherwise, your sampling, there's a sampling bias, and your output can be erroneous. Another type of problem is called a rareness bias. Let's say there is a rare disease. There are some very rare diseases. 1 in 10,000, 1 in million will get. There are some diseases like that. So if there is a rare disease in, say, 1 in 1 million people, and you go and then take a random sample, collect data, and it's quite possible that when you would not have collected even one data point, because it's 1 in a million, and you would have collected from 10,000 people, and you might not have even collected about this particular disease. So this is a rareness problem, and your model would not have anticipated this rareness, and your output will be unpredictable. Another is called a coverage bias. This occurs when population represented in the data set does not match the population that a model is making predictions about. So what you do is I'll explain it. Let's say we are trying to find existence of Alzheimer's disease in patients using the data of their speaking pattern. Right? Now, Alzheimer's people who have this Alzheimer's disease, they have a problem in speaking, so they can't speak fluently. They have some problem. So let's say you use a training data set containing speech samples from native English people, and then you train. And then when you try to use it on a non-native English people, the system can say that all these non-native people have this disease. That is because the non-native English people might not be that fluent. They might be having some accent. They might be dragging some words and then talking. But the AI system might think that all these people are suffering from Alzheimer's disease. So in general, if the algorithm was trained on a data set containing a specific type of patients, then applying the resulting algorithm or model to other types of patients can result in an erroneous result. The algorithm has not been able to learn the details of a wider range of patient types. So that is important. So that coverage is important. But if your AI system is going to be used only in Britain, let's say, then no problem. Use only native English speaking people, and then based on that you can train, because it's not going to be used outside the UK. So that's fine. So it also depends on the purpose. Okay, let's say there is bias in data. How do I detect and how do I eliminate? So there are some techniques I'll just briefly touch upon. There is something called group independent prediction. Okay, this requires that the decisions that are made are independent, or at least conditionally independent, of group membership of the sensitive groups. So there are some measures like group fairness, disparate mistreatment, test fairness. There are some measures. So this group fairness ensures some form of statistical parity for members of different protected groups. Okay, so this is one technique. Equal metrics across groups is another way to do. It requires equal prediction matrices of some sort. Okay, this metrics can be something like, can be about accuracy, it can be about true positive rates, false positive rates, any of these metrics. So across groups we do that. And then this predictive parity, predictive equality, these are some measures that are used to ensure or to detect. Then there is something called individual fairness. This requires that individuals who are similar with respect to the prediction task are treated similarly. Even if they belong to different groups, that's fine. If the two people are similar, then there should be a same. It requires that individuals they are treated similarly in the sense the same type of result should come. And then a causal fairness is another. Okay, it just looks at the causal graph between the data and the outcome. So let's not get detailed because each one is a research paper. Will not go deep into each of these. These methods of approaches to detect and mitigate bias are required if we are going to hand code ourselves to detect or to remove the bias. But nowadays tools are available. We'll talk about it in the next slide. But just for completeness sake, I'm covering this. Similarly, there are ways to mitigate bias, which is like data-based method, which is where you reweight the data. So if for one class of people the weightage is less, you do a reweighting. For example, white versus black, but the training examples are less in the case of black, so you reweight it. And the model-based methods are there. So the first one is data-based, so you reweight it. In model-based methods, so you do some regularization. So people who have done all this deep neural network programming, you know this regularization. You do regularization, and then so that you bring in some fairness. And then there is something called a post hoc method, which is like identifying different decision thresholds for different groups based on a predicted score. Okay, so we'll leave it there. Okay, so there are many tools available for identifying bias and also removing bias. So many are commercial. There are also many open source tools available. Some tools are good for text data. Some tools are good for image input. Some are good for numerical. And there are some tools which are good for ANN, DNN type of algorithms. Some are good for classical algorithms like HMM or GMM. So depending on the algorithm that you use, depending on the type of input data, we can choose the right tool and detect the bias and also eliminate it. Some of the tools I have listed. This is not a complete list. IBM has something called AI Fairness 360, Samatha AI, a few others, Audit AI, and so on. Okay. We'll just next move on to the next important ethical parameter, which is explainability, transparency and explainability. Okay. Okay, 20 minutes. See, the aim of explainable AI is to create a set of ML techniques that produce more explainable models. By default, models will not explain anything. It will just tell you this is what is the prediction, or it will say this is what it is a classification. It is not going to explain anything. The idea is, can models give an explanation of why that output was arrived at? Okay, so that it can be used to audit. It can be used for some improvement purpose, for fine tuning. So that is the purpose. Also, there can be a reason to get explanation because maybe there's a legal requirement to answer to the court, whatever it is. So there can be reasons for that. So if you look at this today, the top portion, this is where it is now, where you get an output, you don't know why it is. Why did I get it? You have no idea. So this tomorrow scenario is what is once you have explainability built in, then you will be able to understand. So the model will be able to explain why that particular image was classified as a cat or a dog. So it will say this I classified as cat because I saw that here there's a fur is there, the whiskers are there, whatever is the feature, it will be able to explain. Okay. So why is this explainable AI helpful? Or where is it helpful? If you see, the explainable AI system don't simply just provide an output, it also gives an explanation. We saw that. Explainable system provide an interface that supplies additional information, or it will present some data inherent to the inner workings of that machine learning system, which will not be obvious outside if you don't have that. So in doing this, Explainable AI system help us to interpret how and why they behave in a certain way. So it helps us better consider their output and provide some sort of a auditing capability so that we know where it went wrong and why it went wrong if it goes wrong. See, another thing is that the AI systems are prone to hacking. It heavily depends on the data. So this data can be manipulated. So this type of manipulation is called adversarial attack. The image classifiers, which are, it's also a AI system, can classify cat or not a cat. Let's say you have a system. Such systems are very much susceptible to this attack. So these image classifiers, what do? They analyze pixel by pixel or a combination of pixel, and based on the strength of the pixel, strength meaning it can be grayscale value or it can be RGB value, and then it based on at a pixel level, a group of pixel level, and all the various layers, it will decide whether it is a cat or dog or cat or not cat. So to hack an image classifier, what a hacker has to do, a hacker can just manipulate a single pixel in an image, which will not be even visible to a human eye. So mathematically, it's possible, even automated way, it's possible to hack a one pixel at a time, change its value, and guide that AI system towards a wrong decision or a wrong classification. The process of finding that exact pixel can be automated. So we need not say. So it will automatically find, and then it will insert a different pixel you can insert, and then you can fool that AI system to make a wrong decision. So this has been proved. Ethical hackers have proved that by manipulating pixels, a machine gun was identified as a helicopter by a AI system. A machine gun was identified as classified as a helicopter by AI system. But it might sound very trivial. So what big deal? Somebody, how it matters? No, because let's look at autonomous vehicle. So autonomous vehicle is looking for, it is driving on its own. It is looking for stop signs and all the signs. What if a hacker manipulates such that the AI system in the autonomous car sees a stop sign as a go sign and then goes and then crashes? So it's possible. So still not convinced. It looks like some Hollywood futuristic nonsense type of thing. No, it has happened. Security researchers from a Chinese company, tech company called Tencent, they just did this. They spoofed a Tesla autopilot system, and they caused it to turn into the wrong lane by manipulating some pixels in the roadside, and they proved that it is possible. Okay, now how can I design an explainable system? How do I do that? See, there is a connection between explainability and complexity. Okay, explainability depends on complexity. So more complex AI system is less explainable. And less complex models are more explainable. So that's that line that shows that. So what do you mean by complexity? How do you measure it? Complexity itself can be measured by three ways. There are three factors or three concepts by which you can measure. One is dimensionality. The more the features, then it is more the dimensions. So features means you have more input variables. So more the dimensions, it becomes more complex. So that is one way of saying whether an AI system is complex or not. So if your input has only based on somebody's height, you are going to decide something, it is only one parameter. Height and weight, two parameters. Height, weight, and then gender, three parameters. So more parameters, more complexity, it has more dimensionality. Then another thing is whether it is a linear system or a non-linear system. Right? Linear systems are less complex. Examples are your linear regression, logistic regression. They are all linear systems. And non-linear models like artificial neural networks, they are all complex. Okay. Another concept is called monotosity, which is it monotonic? When input increases, one parameter of the input increases, if the output also increases, then there is a monotonous relationship. But if sometimes when input increases, the output increases. Sometimes when the input increases, the output goes down. See, if there is no such direct, if there's no monotonicity, then we have it's more complex. So here is an illustration for complexity. Look at this. The first example, we have a linear monotonic two-dimensional model. So the output is 0.8 times x. This is our straight line, right? In other words, for 1 unit increase in age, this is it is a model that maps a customer's age to the predicted number of purchases. So for 1 unit increase of age, the number of purchases increases by 0.8 on the average. So that's what is that linear one. This model's behavior is identical across the feature space, right? Always it is like this. So this model is globally and locally interpretable. And therefore, it is easy for us to explain why, at any point of time, why that particular output came. But if you see, it's also less accurate, because the actual dots you see, and then where this model is showing that straight line, there is so much of error, so much of deviation. But if you look at the second example, it is very close to the actual. If you look at that curve, it is not a straight line, it is a curve. It is going close to those dots. So it is closely following, but it is not a linear function. It is non-linear. Right? At the same time, it is also non-monotonic. So in some places goes up, input goes up, then it also goes down. So there is that is also there. Now, this is for only one feature. Just imagine adding more features, or there is more dimension, and we have a complex system. And for such complex systems, explainability is difficult. See, not all AI techniques are created equal in terms of their capacity for explainability. So I've just listed some of them here, which are explainable, and I'll just leave it there. Do all systems need explainability? Perhaps no. When do we need explainability? If you think reputation is at stake, and so if somebody asks, we have to explain, then you should have. Or if the intention is to fine tune, and then you need to have that feedback so that you can fine tune, then you should have. If you think there's going to be some legal issues and it's better to have explanation ready, then you should have. So it's not that every time you need to have an explainable system. You can switch off the explainer, so that, because explaining, if you switch on explainability, then your model is going to perform slow. So it's better you have it only if it is required. So another important thing which I want to, there are certain parameters about explainability. How do you measure explainability? There are some parameters. It should be actionable. It should be very crisp explanation. It should be very comprehensive explanation, and so on. Okay. There are few ways to get explainability. You can achieve it. If you want to hand code it, you can hand code it, but there are also tools available like Lime, SHAP, ELI5, ML Interpret, which is from Microsoft, AX360 is from IBM. These tools are giving, and some tools are good for certain type of algorithms, certain tools are good for certain type of data. So you try out, and then whichever is good, you can use it. You enable explanation, and then it will tell you why certain decision was made by the AI system. Okay, next I move on to this last part, which is AI and privacy. And as you know, AI can really compromise on privacy. There's a lot of data exploitation that is today going on, and from our buying pattern, from the way we are we are carrying our mobile and going to places, everything is getting tracked and so on. So there is always identification is easy, and even face recognition. So the privacy about that is also an issue. Voice samples are all available. So the voice and facial recognition. These are two identification methods which are being used if you even to in AI systems. Like if you want to enter a room, you can using face recognition or with a voice command you can open. So all those samples, voice samples, face profiles, everything is now available with the AI system. And if you look at AI can also utilize all this algorithm to predict something. Like you even say from the way you are typing, you can even predict whether you are nervous. The way you are talking, you can even find out whether your voice is trembling, whether is it your normal way you talk. So whether you are nervous, whether you are confident, all this it is possible to do because so much of data is already available. We have been talking a lot over phone, and all the data, if somebody wants to collect, is easily available. And also profiling, where I told about China getting into this profiling thing on their citizens. So everybody gets a profile. So this guy is a troublemaker. This guy is a nice guy. This guy will not break. So everybody has been profiled in a certain way. So all this, because of all these privacy intrusions, all this data is now easily available. Now, to protect with a country like China, we can't do much, but with other countries, there are laws now available. For example, there's a General Data Protection Regulation Act, which is European Union Act. And in California, they have this California Consumer Privacy Act, CCPA. And in India, we are now going to enact this data protection law. Now it's in a draft stage. It has gone to, I think, select committee in the parliament. And hopefully in 1 or 2 years, it will be out. But currently, in the absence of this data protection law, we have the IT Act, which is giving some protection for data. So what GDPR expects is, and hopefully other laws will also follow that, is the data should be processed in a fair and transparent manner. It should be collected only for a specific purpose with a specific justification, and it should be only stored and processed only in a certain way. And who can access data, who cannot, who can see which column, who can see which field. And then only need basis data should be accessed. Just because data is there, we should not access. Only to the need basis we should access. All that is expected out of GDPR. Now, the way we have to build privacy into AI system is by building it by design itself. Okay, so we should use the training data only for the stated purpose, and to the extent required we should use. And then wherever possible, you can anonymize the data. For example, you don't want to reveal certain fields, then anonymize it. That is, you can encrypt it or just mask it or do something. But if there's a mask data and you want to do training on mask data, it's a challenge. There are some workarounds for that. How to do training with, there's something called homomorphic encryption, something called federated learning, differential privacy, zero knowledge protocol. These are some techniques available where even with masked data or encrypted data, you can still do training of your AI system. So we can look at that. And then how we can train using minimum data. So usually AI systems need a lot of data to train. So how do you train with minimum data? Of course, transfer learning is there. So when you do transfer learning, you don't need to have that much data. You take that model, pre-existing model, and then do a transfer learning, and then do. So that way they can solve that. So we should be transparent about how the data is processed and explain as much as possible. These are some way you can build that privacy into that. And I have referred to so many websites and so many publications so I'm not listed. It's going to be a big list, so I'm not there. So I wish to thank all the authors of all these sources for this for preparing this presentation. Thank you.
Thank you, sir. Thank you. It was very informative and useful session, sir.
Thank you.
Thank you so much for spending your valuable time with us. On behalf of SKCET, once again, I thank our resource person, Mr. Sridharan Sankaran, sir, and all the participants of this session. Thank you,
Thank
Ananda.
Thank you.
Sridharan sir, thank you, sir. This is from
Thank you.
Priya. Really
Thank
very
you.
session. Thank you so much for accepting our invitation. And
My pleasure. Thanks for inviting me. It was my pleasure.
thank you, sir. Thank you.